Good day, everyone. My name is Chinmay, and today I will be discussing an important concept in network routing, route summarization, and aggregation. This technique plays a crucial role in optimizing routing tables, improving network efficiency, and reducing overhead in large scale networks. To fully understand this topic, we will follow a structured approach. Let's first define route summarization, understand what a routing table is and why it is needed, discuss the need for route summarization, explain how the IP packets flow and where route summarization comes into picture. Let's go let's go to the flow one by one. Route summarization, also known as supernetting. It is the process of consolidating multiple IP addresses prefixes into a single summary route. This is done to reduce the size of routing table and optimize network performance. For example, if a network has multiple subnets like 192.168.1.0/24, similarly, at the third octet, uh, the one is replaced with 2, 3, 4, etc. Now, instead of storing and advertising all these routes separately, a router can summarize them as 192.168.0.0/22. It's a uh, it's a process that we'll be discussing further, reducing the number of entries in the routing table. What is a routing table and why it is needed? Uh, so, the need of routing table helps us ensure that data packets reach their intended destination efficiently. It helps routers make forwarding decisions dynamically. It prevents unnecessary broadcasting, reducing network congestion. However, as networks grow, routing tables become large, leading to increased memory usage and processing delays. This is where route summarization becomes essential. So, need for route summarization. Large networks such as those used by ISPs and like internet service providers and enterprises often have thousands of routes. Maintaining such a vast routing table can lead to increased memory usage, where routers need more storage space for large tables, higher processing overhead. Searching through a large table increases packet forwarding delays. Frequent route updates. When individual routes change, updates must be sent across the network, consuming bandwidth. By summarizing multiple routes into a single entry, we can reduce the size of routing tables, improve network efficiency and speed, decrease the number of route updates, and enhancing stability. Flow of IP packets and a role of route summarization. So, as you can see here in the picture, uh, let's suppose a person has a local area network, and the local area network router is connected to various devices, and various devices have each been assigned to a IP address. Whenever, let's suppose, take an example of whenever an email is sent by an user. So first of all, the IP address packaging happens, which involves IP address, destination, and other important data for the transfer and to receive at the destination. So as you can see here, uh, the subnets are entered into the data table of the router, which has address to the next hop into the network. So what happens is, the this data table gradually increases in size if we enter manually every address that the message needs to reach to the destination. Hence, what actually a route summarization does is that it combines 2 to 3 hops into a single, what we can say, IP packaging, where the summarization of the path actually happens instead of hopping and making a decision at every hop. So, routing table lookup and next hop decision. Once the packet reaches the sender's router, the router checks its routing table to determine the best path towards the destination. If the destination is in the same subnet, the package is delivered directly. If the destination is in a different subnet, the router must forward the packet to the next router based on the longest prefix match. The router examines all network prefixes in its routing table. The route will be the longest matching subnet mask that is chosen. For example, if a packet has a destination IP address of 192.168.3.5, the router checks up to all the octets, and the best possible match that is more that will be more specific to the subnet will be applied to the summarization. For example, 192.168.0.0/16. Similarly, the third octet will change. 3.0/24 will be summarized to 192.168.0.0/22. If the route summarization is applied, the lookup table is much faster as the router can quickly find the summarized route instead of checking multiple individual entries. Packet forwarding across multiple routers. Uh, this is the demonstration of what we discussed earlier. Let's jump to the next slide and how summarized IP routes improve efficiency. So first of all, that is aggregation of multiple hops. A summarized route represents multiple subnet paths. Second, efficient next hop selection. The router, upon receiving a packet, checks the summarized entry and forwards the packet to the next correct hop. Hierarchical routing. Higher level routers store only summarized routes, while low, lower level routers maintain specific subnets, reducing overhead. Faster packet forwarding. The summarized route allows routers to match the packets with fewer comparisons, reducing lookup time. When a subnet changes, only its intermediate router updates, preventing the unnecessary updates across all the network. For example, an ISP router stores an IP address, let's say 10.1.0.0/16, which could represent two subnets, two IP addresses that will be two hops. Let's go to the next slide. How summarized IP improves efficiency. So let's go to the next slide. As we seen now, faster lookup with fewer routes to scan. The router finds the next hop quickly. Efficient hop selection, reduced load in the memory, and minimized updates. Packet reception and decapsulation. Once the packet reaches the destination network, the final router uses ARP or address resolution protocol to find the MAC address of the receiver. The packet is then sent to the recipient's device where the IP header is removed and the email message is delivered to the user's application. Route summarization plays a crucial role in improving network efficiency by reducing the routing table sizes and optimizing packet forwarding. By implementing it correctly, the network administrators can enhance scalability, minimize processing overhead, and ensure a stable routing environment. Thank you for your attention.